Hello, this is Carl Irwin with episode 5 of Hacking the Viewport. Today we're going to be looking very briefly at the more appropriate conventional applications of materials in the viewport using the material settings and some of the new features that are on the Gooseberry project daily builds right now, things that will hopefully be making it into the standard release of Blender very, very soon. And we're going to be looking at ambient occlusion and depth of field and applying those and using them in a more conventional way from the viewport. In the last episode, if you watched it, you saw that we looked at some of these things and utilizing them as render passes, creating masks and mats that could be used then as separate passes composited together in a compositor in order to create an end result. Today we're going to look more at the appropriate application of these features so as to get an in-camera, in-viewport result as best we can. What we're going to do, excuse me, is we're going to create this animation here, which looks really kind of disgusting. If you look at it, it looks like kind of a clump of cells glibbing and globbing around in the camera. You can see there's a few effects going on. You can see the ambient occlusion. You can see some specularity in the material and some, bump mapping looks like is going on here. You can also see there is some depth of field in that the very front of this icky thing is in focus, and then as it moves away from the camera it kind of falls off. There's also an application of a mist layer in here so that it gives us some three-dimensional depth. So if this is in kind of an atmosphere, there's a little bit of atmospheric fall off in this scene. And let me see what else is in here. There's a little bit of a hint of subsurface scattering. Someone showed me very recently a very quick and dirty way to get kind of a very basic essence of subsurface scattering that I will show to you very quickly here that you can use in order to get that kind of effect very quickly right in the regular material applications using the node editor. So one more time, here's this animation. Also, we're going to look briefly at some animation, being able to do some object duplication and animate using three-dimensional textures. One person wrote on a recent tutorial, asked me what my thoughts were on Video Copilot's Element 3D, considering that I'm doing a lot of OpenGL kinds of tutorials. Element 3D is a plugin for After Effects made by Andrew Kramer at Video Copilot that uses OpenGL and GLSL types of rendering in order to create three-dimensional space for three-dimensional models and objects, fully materialed objects, in order to create a layer for those objects in a composition or in a composite sort of situation. And I responded that really I don't think too much about Element. I know what it is. It's really clever. It's a great piece of software. For those of you that use After Effects, I don't use After Effects, but if you do, it seems to me like I'd save up some money and get that plugin because it's pretty powerful. I use Blender, and that's my hobby, and that's what I do, and I don't really mess around too much with many other pieces of software, and I don't have an interest in doing that. I don't have an interest in making those purchases. I don't have a need to, so I'm perfectly happy doing what I'm doing. My answer was that I don't really think that the two are much of a comparison. They do very different things. However, that being said, I do want to point out that Blender's modeling features have been able to do a lot of these things that you can do in Element 3D, such as object duplication and three-dimensional texture application for animation. That's been in Blender for a very long time, and I'm going to show you how to do that in order to create this sort of an animation, which actually looks very similar to an animation that I saw for a demo for Element 3D. So that's kind of where I got my motivation to try something like this. Before we get into this, though, I want to point you to some resources. You might notice in Blender there are MatCaps, or material captures, is what that stands for, a captured material. And what a captured material is, in fact, if we go to Google here real quick, a material capture is an image that captures all of the elements of an atmosphere or a location for a material in that one image. And you can see here it's usually a spherical type effect, and the way this would be applied is using sort of a normal map, such that, for example, on this example here, the part that is central would be the normals that are facing the camera, and as you move to the right, the normals that start to face at an angle towards the right perpendicular to the camera would inherit these types of properties of the material. Okay, so that a sphere with this MatCap applied would look just like this image. We see MatCaps in Blender in the this is the scene we're going to look at here. But if you look, we see MatCaps in the solid view. And if you look over here under the shading mode, it'll say MatCap. If I click on that, it will apply a MatCap. And Blender has a little library of MatCaps. And these are for modeling purposes. It's to give you a preview using a very generic material of what your object would look like if a material were applied to it. So that is the purpose of MatCaps, is to use in modeling. Now, we can actually use MatCaps to texture and material something for production rendering. And Element 3D does very similar things in the application of its materials. So I'm going to show you how to build those types of materials from scratch. And what I wanted to point you to was this website here. It's a DeviantArt post. I downloaded these a couple years ago, but it's 163 MatCaps that have been put together from a couple of different resources. So it's a free resource, and this is a very, very powerful, useful tool. You can apply these then in the just general material settings rather than trying to suffer with just the Blender MatCaps in the solid viewport, solid viewing mode. So let's take a look at this project here. If I go back to the beginning and we play this back, you can see that this plays in relative real time. It's a little bit slow. It's moving kind of at a slow frame rate. You could turn on frame dropping to get a better sense, but it would be cutting out some frames there. But this is a pretty good preview that it is animated, it is moving, and you see really exactly what it will look like when you render. If we pause for a second and I hit the render button, we render one frame at 720p. This will render in just a couple of seconds, and you can see that this is a single frame of our scene. And it's got all of the effects in it, the ambient occlusion, the depth of field, everything's in there, plus the materials. So this is what it is, and everything that you see in the video is here in the viewport. So let's take a closer look at what's going on here. The first thing that we want to look at is what is involved in this object. So let's go back to the solid view, and I'm going to turn off the ambient occlusion and the depth of field, and also let's apply a MatCap so we can see the objects a little bit better. I'll find a more generic looking one, maybe this one here. That's hard to see. Let's try this one. Okay, there we go. So we have these gray spheres, and what this is just an icosphere that is parented to a larger icosphere. And this larger parented icosphere, if I hit tab, so you can see what it looks like in edit mode. It's just an icosphere with the other ones parented to it. And what you can do on the parenting object is go to the object settings and enable the duplication. So this is enabling duplication by vertices, and I have rotation set, and that's going to be more for the mapping of textures later on, so that they don't look completely uniform from icosphere to icosphere. But you can duplicate that parented object on each vertex using this, or each face or group or whatever you want to do using this tool right here. So if we tab back out of edit mode, the icosphere itself, if I hit tab on that, you can see here it is. There's just one at the center of the parented object, and it is UV unwrapped so that we can apply some UV applied materials and textures later on. And tab back out of edit mode, and you can see that this is what object duplication does. Now, in order to get this shape, we go to the parenting object, the parent object, and we apply a modifier. I applied a displacement modifier. The coordinates are set to an object, and inside of the scene is an empty in there, and the empty drives around our three-dimensional cloud texture. And if we look at the texture, it's just a general cloud texture set to this size, very low depth, so it's kind of blotchy. As that point moves around, that empty moves around in the scene, it will then animate our object in this way. In addition to that, you can also animate the parent object by setting some rotations or any other kind of location animation, and it will rotate and it will animate through that texture in three-dimensional space. Also, you can't really see it here, but if I go back to the texture view, you could take the icosphere, the parented icosphere, and rotate that on any axis, and it will animate those UV textures, those ones that are UV mapped, and give you some additional animation. So a combination of different animation procedures, moving the empty around to move the texture in space, moving the parented icosphere, the parent icosphere, and moving the parented icosphere, you can get some really interesting kinds of results. And it looks kind of like this. Now, if we are to apply our Gooseberry upgrades, our ambient occlusion, you can see what that adds to it, and then also our depth of field, turn on the only render, and you can see that all these things put together get this output. Now, one other feature that is applied here is the mist feature. So you want to make sure that your object, the main object under the material, has mist enabled, and by default it should be. And then under the world settings, you want to make sure that mist is enabled, and this is always off by default. So once you enable it, you want to select your world color to be the background color. So you do a color choose and pick up on your background color. This is just a background image set in the background image output. So this is not actually in the scene. It's just set as a background image in the camera view. You could put a plane in the background of the scene, but I found that it rendered a little bit more quickly if I just used a pre-made background image with this vignette already on it. Anyway, you set your background color, and we have this mist fall off set really tight. So at 12.5 blender units from the camera, the mist will start to apply, and then it ends at a depth of 14 blender units away, which is really just at the back side of this object. So as it gets further away from the camera, it starts to turn a little bit more light blue. Now you'll notice that there's a problem here if I turn off my depth of field with the ambient occlusion layer, and that it is not affected by the mist. The ambient occlusion layer, the way it is designed, is applied on top of the mist. So you have to kind of find a happy medium when using both of these together. If you want to get an authentic application of mist and ambient occlusion, I would recommend that you use the technique that I demonstrated in the last episode in creating a render pass with your ambient occlusion color set to white, create a pass for your ambient occlusion, and then apply it separately along with your mist as a pass in compositing later on. So that's what I would recommend that you do if you want everything to work properly. But if you find kind of a happy medium where these two things balance out, you can get away with it, and that's what we're doing here. So this is the animation side of what's going on, and the basics of the Gooseberry upgrades that have been added to the latest Blender builds. One quick thing about depth of field. We didn't talk much about depth of field last time. We talked a little bit about the ambient occlusion and some of the settings there. You need to turn up your darkening, sets how dark your shadows are going to be, and the distance fall off for that. But depth of field, let me explain how depth of field works. If you use cameras, real physical cameras, a DSLR or something like that, that is able to do depth of field and has that capability in the lens, meaning that the lens has an aperture in it, the ability to open and close an aperture and allow more or less light in. You understand this a little bit, perhaps. Maybe not, and this explanation might help you understand a little bit for your camera. The f-stop is the amount of light that the aperture allows in. So the bigger the aperture, the more round the aperture, and the widest opening of the aperture, the more the light comes in. That is indicated by a low value on the f-stop. So a 1 is a really big aperture, meaning that a great deal of light is coming into the camera. And that's what causes our blurring effect, okay? The focal length gives us a parameter at which parts are going to be in focus versus those parts in front or behind it which go out of focus. So you change this value to change that depth in your depth of field. Okay, so a low number here and then an increasing number give us about this kind of an output. If I turn this up maybe to 100, my focal, you can see everything gets blurry. So the higher this number, the tighter that range. There's a really tiny little sliver in there that's in focus and everything else is out of focus. And as this comes down, say to 50, now you see there's a little spots that are in focus, and maybe we go down to 25 from here, cut that in half, and you can see now it's tiny little pieces in focus here, a little bit more. And if we go to 6, which is where we want it, we have a little fringe back there that's out of focus, but mostly it's in focus in the front. So that's depth of field in a nutshell. The higher this number, if I turn the f-stop way up to 100, that's allowing very little light in, and essentially all of our blur goes away. Okay, so you want your f-stop to be very, very low. And on your cameras, if you're going for that cinematic film effect where the background is out of focus, you want your f-stop to be pretty low as you can get it, usually. Okay, so that's depth of field along with the ambient occlusion. I talked a little bit about that in the last tutorial, so I'll end my spiel there for right now. Let's look at materials real quick. All we need to do is apply our materials to the parented icosphere, and then it will apply to all of the others. So if we look under the material tab here, you can see that nodes are enabled. If I turn actually that node back on, you can see what the composite output is here. Look at this example. You can see this model, this texture model, where we have a very harsh specularity, but then a very light fall off on the specularity, which is a little bit more realistic looking. This is something that was just added to Element 3D. We've been able to do this in Blender for a long time because we can use nodes to composite different materials together. So let me show you how I did that. If we disable the node on here, we can look at the first material, which has a very typical default Cocteau specularity to it. It's a red color, and then under the texture slots we have a few things applied. The first one is a hammered metal texture, so it looks like it's a bunch of divots on it. You can see this has been UV mapped. You can see that if you get really close, you can see where the UV map cuts off a little bit. Because the texture is so busy, it really doesn't matter, but you might want to smooth out some of those lines a little bit. But that's the first texture, and this is set applied as a UV map, really, really tiny in size, and I'm using the geometry of it to give us kind of a bump map. So the darker spots look like divots, the lighter spots look like something that's more convex, okay, and light catching. There are real lights in this scene. I have it set up at a 3-point light, so there's a blue light on the right, an orange light on the left, and then a white light up behind, giving us kind of a backlight. And actually, to my 3-point setup, I added one more low light on the bottom to give a little bit of a light from the bottom there. So nothing in here is shadeless, everything is shaded. So that's the first thing, the bump map. The next texture that I applied is a MatCap, a captured material, and it looks like this. And this is just part of a collection, that 163 MatCaps, and it's just a reflection kind of thing. I applied it with the color set very low to 0.1, and I set it on an add blend mode, so it would just take the highlights and add it to our material. And you can see that that bump map affects that reflection, and it is also set to reflection coordinates. So it's not set to normal, it's set to reflection. If I wanted it to work as a MatCap, I would set it to normal. Okay? And then the next thing that I applied, the last texture, is another a hammered metal texture. It's the same one. However, the white spots have been alpha transparent enabled, so it's just the shadow. And you can see, if you look really close, we have these ring sorts of shadows on here to just help sell the bump map a little bit more. Okay, so that's all of the material blended together in the texture slots. Now what I did is I duplicated that material and I made this one down here. I changed the red color to a black color, and I changed the specularity model to Ward ISO, and I turned the specularity slope down until I got a really, really stark point. Okay, so then what I did is I enabled nodes on the first material, and if we go into the node setup, I'll show you what's happening here. So under the node editor, what I have is the first texture coming in, and then it's applied to an add color node with the second texture added to it underneath. And it's set to 0.5 right now. If I set this all the way up to 0.1, we'll get a little bit better feel of it. We'll see a lot more of that specularity. So this is the outcome of that adding blend mode of those two textures. So we get the specular highlights of the second one, plus the softer specularity of the first one. It's really, really interesting kind of look, almost as if this was a wet kind of surface, so that there's a bit of a subsurface scattering. Now, about subsurface scattering, we can create kind of a cheap version of that by duplicating. This is a trick that someone taught me not too long ago. If we duplicate our first material, let me slide this up. And then we're going to enable this setting here, invert normal. And what it's going to do is it's going to give us a view of our object as if it is a one-way mirror, or rather a two-way mirror, so that we're looking through the outside into the interior of the object, and we're seeing the light bounce off of the inside edges. Okay, so by inverting the normals, now we have an inside view of this object with the same material setting, and it's picking up light. Now, subsurface scattering is essentially just the occurrence of light entering into an object, bouncing around through its material, and then causing a glow in its refraction and reflection back through it. Okay, so kind of like a skin look to it. What we can do is we can take this material, and you'll see what it looks like here on our object if I apply it. We can take this material and we can set, let me see here, if I select a curve, RGB curve, and we set maybe a contrast curve to this. Maybe I'll bump up the high end a little bit, bring down the low end a little bit, and now we're getting more of what we want. So we're getting kind of this fringing effect, this glowing sort of effect a little bit in there. And we'll turn it down a little bit. Now if we add this to our first material, and we'll actually just duplicate this add mix node, move it over here. We'll bring the output from our subsurface material down, and we'll see what we get. So that's looking a little bit better. So it looks like it's kind of got a glow to it in certain areas. Now if we turn our depth of field and our ambient occlusion back on and our only render, so now it looks a little bit more like it has a little bit more body to it, a little bit more depth. So we're compositing our materials together to make a more complex in-camera materials. So this is a more traditional application of materials inside of the Viewport, and you can see even using lighting and the typical material setups, you can get some really convincing effects with these new features, the depth of field and ambient occlusion. And again, if I play this back, it plays back with a pretty good preview in relative real time here. So anyway, that's the project, and that's these new features in the Gooseberry versions that are out. You can download daily builds at blender.org. Go to the development page and go to daily builds, and you'll find the Gooseberry project builds ongoing. And that's how we can apply captured materials and composite materials together. Lots of really good stuff in this tutorial. So it's important that you understand the traditional applications of materials before we venture into the non-traditional applications of materials on 3D objects. In the next episode, we're going to be looking actually back at our original project and generating that planetary and asteroid field kind of set of objects using some of these techniques, but we will be faking our ambient occlusion using a different method that works a little bit faster and can be used in certain unique circumstances using light masks. So I look forward to that next episode, and I'm glad I got to share some of these more conventional methods with you today before moving on with that. So again, this is Carl Irwin, and I hope you find this useful. I hope you find uses for it in your projects, and I wish all of you happy blending.